Okay, Vaishnavi, let's start. Uh, Please tell me about yourself. Where are you from? Oh, sorry. What are you preparing for? And what is your qualification?
Okay, sir. My name is Vaishnavi Chaudhary, and I'm belong to Bhusawal, Maharashtra, and I'm preparing for DRDO.
DRDO. Okay. And you have done B.Tech, M.Tech, PhD. What?
Yeah, B.Tech in mechanical engineering.
B.Tech in mechanical. And what subjects have you prepared today?
Heat transfer.
Heat transfer. Okay. All right. What is heat generation?
Heat generation.
Yeah, heat generation.
Heat generation is the heat generated in the substance because of any internal irreversibility like friction.
Okay. That's all.
Yes.
Give an example of any substance which is generating heat.
Means internal heat generation.
Yeah. Can you name an example where you have seen internal heat generation happening?
We can take example of wire.
Okay, wire. Okay. How is it happening in wires?
If electric current flows through wire, so because of that there is extreme high temperature. Because of extreme high temperature, there is a heat generation takes place.
Okay, when current flows through the wire, why will that wire produce heat? My question is this.
Because of current flowing high voltage, because of high voltage, means that heat generated, we provide insulation on wire, and because of that the heat generated inside can't move outside, so it is in the wire.
Okay, let's wait. Gaurav Tiwari. Hello.
Yes, sir. Yes,
So
sir.
today,
Am I audible, sir?
yes, you are audible. Today's slots are already distributed. You are late, and please join tomorrow.
Okay, sir. Fine, sir.
Okay.
Thank you, sir.
Okay. Okay. So let us have an example. Okay. I will just share my screen and I don't know. So I will try to make it correctly because okay, this is a slab. Okay. So we are having temperature T1 here and temperature T2 here. Okay. So if conductivity K is constant inside the body and there is no heat generation happening, what kind of profile are we?
Okay, we will get linear temperature profile in the decreasing form.
Okay, linear when T1 and T2 are different. Like if T1 is greater than T2, then we will get a linear, right?
Yes,
So this problem that we have solved, is it a steady state or unsteady problem?
steady state form.
Okay. So I came to another problem now. We have a similar kind of slab. I put that slab in an oven.
Okay,
How will temperature change in the slab? Well, basically variation of temperature inside the slab.
in case of oven, temperature will remain constant because
Can you
yeah,
draw it in on your page? We put that slab into oven and then draw temperature profile inside the slab. How will it vary? And let me know. Just okay.
okay. we will consider it adiabatic process. No,
What?
isothermal process. Temperature will remain.
Temperature will remain constant.
Means no, 1 minute. That this T1 and T2 condition will remain same.
No,
No.
it's totally different problem. I put in the Oman. The question is not connected with the previous question. First of all, okay, I will just draw it again. So this is a bigger room which is called oven. Okay, and we have a place slab inside it. Oven temperature is nearly 3000 Kelvin. Okay, initially it was at room temperature. Inside it was room temperature. Now suddenly it is put into an environment of 3000 Kelvin. So how will temperature change inside the slab?
Exponential.
Exponential. I mean, can you draw the curve inside the slab? How will it change? I'm okay. Just keep. Tell me first your answers. You can take some assumptions if you want.
I'm considering it lumped heat cap.
Very good. And why? How will you check if it is lumped heat or not? Do you have any criteria?
Biot number if less than 0.1, then I will consider it lumped.
What is Biot number?
Biot number is the ratio of external conduction resistance to the internal conductance resistance to the external convection resistance ratio.
And how is it different from Nusselt number?
Generally, we take Nusselt number for fluid and Biot number is for solid. So
Okay.
it will be exponentially increasing.
Okay.
Is it visible?
Just wait a second. I have to stop sharing. Okay.
It is downward.
Okay. Okay. That's fine. You have plotted in terms of temperature. Oh, sorry. Temperature versus time. Okay.
Time.
That's fine. Yeah. Okay. Okay. My last question to you is I will draw another figure. So you have a room. Okay. And that room have one wall on this side, one wall on this side. We are not considering any temperature variation in through this wall. Okay, we are considering the adiabatic wall. Okay, we are considering temperature variation only in this direction. Okay,
Okay.
so temperature on this side of the wall is T1. This is T atmospheric, and this is T2. T2 is greater than T atmospheric and T1 is less than T atmospheric. I want to have temperature variation in this room. So there is air here, there is solid wall here. This is also solid wall. Both have same conductivity K and we have air in between. So I want to know how will temperature change throughout this room from the left wall to the right wall.
Okay. In case of first wall, there will be conduction takes place. Then
Okay.
after that, through air, there will be convection, and again there will be conduction. So
Okay.
thermal conductivity is also same for both walls.
Yeah.
Okay. Can I draw text profile?
Yeah, sure.
So light this one.
Okay.
At middle one, it's because of convection,
Okay. So
and slope will be
Just-
same for first wall and second
okay,
wall.
okay. Just wait for a second. Satish, hello.
Yes, oh, yes, sir.
Yeah, join at 9:55. Yeah.
9:55. Okay, sir.
Yeah. Okay. Leave now. Okay. Okay. Let's come to the middle portion where air is present. Okay. You are saying convection is happening, right? So what is your assumption here? Are you taking any assumption over there, or there are no assumptions?
Steady state condition.
Okay. That's okay. Any other assumption are you taking for that side? Okay.
Um,
What is happening near the wall? Both the walls.
what, sir?
What is happening near both the walls? How will air flow inside it? What will be the direction of airflow? Can you comment on that?
Direction of airflow from T2 to TA. Since T2 is higher, so it will flow from T2 to TA.
What is how it is flowing from T2 to TA? Just wait. I will come back to the figure first. Okay. So from T2 to TA. So you are saying that a direction of airflow is in this direction.
No, means from left to right.
How are you sure about it? Can you explain physically how it is happening?
It will be decreasing, linearly decreasing in first wall.
I don't understand why air will flow in the right direction, left to right. Why will air flow in that direction?
Because of temperature, means T2 is greater than TA, so heat transfer will take place from higher temperature to lower.
So heat transfer is flowing from this direction, that I understand. Why will air flow in that direction? My question is, you are saying heat transfer is taking place in this direction. That is fine. Why will air?
Air is flowing?
Sorry?
Why air is flowing in that direction?
Yeah.
Then,
Yeah.
at the left side wall, there will be high temperature of air. So
Okay.
the high temperature molecules of air will flow from left side to right side.
What force is forcing them to move to that direction? I don't understand that. Buoyancy force will move upward. Why will they move right?
Sorry, density difference. Because it can't flow from upward and downward direction. We're considering it is insulated, so it will flow only in this direction.
Okay. Okay, I'm not sure about your answer till now. Okay, you are saying that air will flow, not flow upwards. Okay, this is the. It will only flow in this direction, right?
Means if it will be flow in that direction, upward or downward, but it will not go out. Means its temperature. Means heat transfer will not go outside from that wall.
Okay, then.
Insulated.
So you want to say that the air that is moving upward will move this side?
Yeah, it will move towards lower.
Because there is a wall, it will move this side. That is understand. This is good. This is nice. Now, why will it come down from here?
Because it's giving it heat to that molecules at that side, and because of then it temperature will lose, so density will decrease,
and then it will go here because the whole momentum is forcing it to go there. So if I just consider this wall, what is happening here?
Means wall boundary, at wall boundary.
Yeah. What is happening over there?
Okay. There will be convection. Means from wall there will be heat transfer to the air molecules at that wall.
Okay, that is fine. That is already clear.
Yeah.
Okay, Vaishnavi. You have done very good till now. Just only one thing you have missed in this whole answer. You have not mentioned any boundary layer formation.
Boundary layer.
Yeah. Boundary layer will be forming near the walls.
Case of air.
Only that thing is missing in your answer. Everything you have done answered right. Okay.
Boundary layer will form.
Boundary condition. Oh, sorry, boundary layer formation. When the air molecule will get in touch with this one, it will try to move upwards, and there will be a boundary layer formation. And interesting part is that suppose I will just rub it a little bit. Is okay. Okay. Interesting thing is that in this part it will be a linear decrease of the temperature, right? And
Yes.
then suppose this is the boundary layer here. So the temperature variation will be like this
Yeah.
in this portion. After
Temperature
there is no
profile.
variation. It is a constant temperature. And
Means
suppose here the boundary layer will be like this. And how will it move? Like this or like this? Downward or up? Downward.
downward.
Yeah. So downward like this or like this. Which one is correct?
First one.
Just I will erase a little bit again. Okay. So suppose this is the boundary layer. So you are saying this one.
Yes.
Why?
Because the temperature is decreasing,
Huh?
so there should be slope also decreasing.
So it's wrong. Okay. So it will be like this.
Okay. Why is this?
Why? Because at this point del T by del X should be 0. And at this time gradient should be high at this point. Similarly here, gradient is high at this point and gradient is 0 at this point. This is the basically reason of the boundary layer. Okay, temperature variation is happening very fast near the wall and it is coming to 0. The gradient will come to 0. Okay, so this is the condition. After that, when it comes like this, just let me think, am I right? It will go like this again. Okay,
Got it. Okay.
now it is all clear. Okay,
Okay.
everything else was correctly answered. Okay, biot number was right, Nusselt number was right. Even there is one more question people ask about this. If we have a composite wall here, like there are two different conductivities, K1 and K2.
Okay.
So can you draw a transient temperature profile in this at any point? So it will be, suppose K1 is greater than K2. So slope in K1 will be more than K2?
No, it will be lower.
Okay, it will be lower, right? So if conductivity is more, slope is less. Okay, so if T1 and T2 are both same, it should be like this. So both are same, slope are different. So at interface, we are getting two different temperatures.
Yes.
But it cannot happen. Temperatures at an interface should be same.
Same. Yes.
What will happen here?
Conductivity is different.
Conductivity of both the material is different. If I start from here, I come here. If I start from here, I come here. So we're getting different temperatures here.
First one will
Which one is correct? इन दोनों में से एक तो गलत है. Okay, think about it, and if you have the answer, come to the next time in my in this session. Okay, think about it. Okay.
इन दोनों में से एक गलत है, वही बोला ना आपने.
इन दोनों में से एक तो गलत है, लेकिन असल सही क्या है ये भी बनाना है.
मतलब कंडक्टिविटी पहले की K1 ज्यादा है K2 से.
कोई भी एक ज्यादा कर लो, टेम्परेचर T1 T2 सेम है, ट्रांजिएंट प्रोफाइल है ना. जनरली क्या होगा, धीरे धीरे सब जगह T1 हो जाएगा, पर शुरू में कुछ ना कुछ ट्रांजिएंट प्रोफाइल तो आएगी ना.
हाँ हाँ.
उसको फाइंड आउट करना है भी क्या आएगी.
ओके.
ठीक है, अगर सिंगल मटेरियल है तो क्या आएगी वो भी सोचना है, इसके बारे में वो भी बताना मेरे को.
ओके.
ठीक है.
एक मतलब अगर हम ओवन कंसीडर करें तो उसका तो टेम्परेचर चारों साइड से सेम ही रहेगा.
हाँ.
तो फिर मतलब बाउंड्री के बाहर का टेम्परेचर सेम ही है, सिर्फ अंदर वेरिएशन कैलकुलेट करना है.
ठीक है, इसके बारे में सोचना और बताना मेरे को. ये बार्क बाबा एटॉमिक रिसर्च सेंटर्स में पूछा गया क्वेश्चन है. ओके, वर्क ऑन इट. ओके, गुड. See you.
Thank you.